My measures of spread, we talk about our variance and our standard deviation. All right. Now the variance on our formula sheet, it's the same rule. The only thing that changes is the way in which we work it out. All right. So my variance given here, e of x squared minus e of x all squared. All right. So how do I work out e of x squared? It's the same as just putting x squared in my function and multiplying it by f of x, then minusing my expected value of x. All right. The little relationship of variance of ax plus b is the same as a squared times the variance of x, the same as a discrete distribution. My standard deviation is the square root of the variance, which is the same as my discrete distributions. So really, it's only the working out that is a little bit different. All right, so let's have a look. So my variance of x, find the variance. So the variance of x is equal to e of x squared minus e of x squared, which is equal to the integral between 0 and 2 of a half x times x squared dx minus the integral between 0 and 2 of a half x times x dx all squared. Okay, so let's work them out separately. So I get the integral between 0 and 2 of a half x cubed dx, which is equal to a half of x to the 4 on 4 between 2 and 0, which is a half of 16 on 4 in total, which is equal to, what's that, 2. And we worked out the other one before, 0 to 2 of a half x squared dx, which is a half times x to the 3 on 3 between 2 and 0, which is a half times 8 on 3, which is equal to 4 on 3. Go here. Therefore, the variance of x is equal to 2 minus 4 on 3 squared, which is 2 minus 16 on 9, which is 18 on 9 minus 16 on 9, which is 2 on 9. So that's my variance. Therefore, the standard deviation of x, square root of 2 on 9, which is equal to root 2 on 3. So find the variance and standard deviation, okay? So again, same formula, it's just the way in which you work out the probability is slightly different. If I want to know the interquartile range, that's the difference between Q3 and Q1. So my interquartile range will be the probability equal to 0.75, subtract the probability equal to 0.25. So let's have another play with that one. So Q3 is, we have to find the value of m. Now, okay, so we want to find between m and 0 of a half x dx equal to 3/4, which implies then we get a half of x to the 2 on 2 between m and 0 equal to 3/4, which gives me a half of m squared on 2. So let's solve there. So multiply the 2 across. M squared on 2 is equal to 3 on 2. M squared is equal to 3. So m equals plus or minus 3. So clearly m has to equal positive 3. Oh dear, what's happened there? What's happened there? Obviously that's plus or minus root 3, which makes sense. So m has to equal positive root 3. So that's my upper quartile. So if I was to sketch my graph here at 0.5x, we're saying up to 2. What I'm saying is that here at root 3, that section there is 0.25. Yeah, because the other section is 0.75. So now, if I want to find Q1, which is equal to from 0 to m 1/2 x dx, but this time equal to 1/4. See, everything's very similar, isn't it? It's a half. The only thing that changes is it's 1/4 on the right-hand side. So it's equal to 1/2 of m squared on 2. So we've got multiplied by 2, multiplied by 2, so I've actually got m squared is equal to 1, so m equals plus or minus 1. Therefore Q1 is equal to positive 1. In the same way, Q3 is equal to positive root 3. So now if I go to the questions, the range is just high minus low. So at x equal to 2, that's the point there, 2, 1. So it's just 1 minus 0, so the range is 1. Interquartile range is equal to Q3 minus Q1, which is equal to root 3 minus 1. Okay, off you go.